and welcome. In this lecture, we'll look at regularization. Regularization is a technique that we use to prevent or to overcome overfitting. We mentioned that overfitting is one challenge that we have in neural networks. That's because we have so many parameters in neural networks. In the example we saw in the previous lecture, we had 784 inputs with 512 neurons. So the weight of that gets transferred or serves as an input to your next layer, and that gets connected to 512 neurons, and the weight of that gets transferred to the next layer, and you easily have at least 1 million parameters when you multiply all of that. So to overcome that, we'll use a technique known as dropout. There are a few regularization techniques, but the one we'll look at in this lecture is called dropout. Okay, to explain dropout, let's consider the following example. Let's say we have 100 neurons. So if I make a range here, okay, 100 is a lot. Let's consider 20 just for this example. Let's say we have 20 neurons. So what happens while we train our model is that, so without any dropout, if we consider this example, out of this 20 neurons, each neuron has a chance to be used for training or not, right? So the availability of a single neuron for training or not is 50-50. So in a normal situation without any dropouts, 50% of these neurons can be used for training, whereas the other person cannot be used for training, right? There's a 50-50 chance. And what dropout does is that it will drop some of these neurons. These are also called nodes. You might hear of nodes or neurons. So dropout will drop some of these neurons. That way there won't be any connection with those neurons, and we cannot use those neurons for training. So when the output from a previous layer goes or serves as an input for the next layer, and if the next layer has, let's say, 20 neurons, some of these neurons will be dropped out. So they won't be connected to your previous output. Okay? And using that mechanism, our model will handle noise much more efficiently. Okay? And we specify dropouts by probability. We can specify, let's say, 20% or 30%. If we use 20%, that's 0.2. What it does is, so 20% of 20 is 4. These neurons will be dropped out, so they won't be connected to your previous input. So only the remaining neurons will be used for training. So by using this mechanism, we can handle noise much more efficient. Okay, that's what dropout means briefly, and you can read more about it in the documentation. So we have used 512 neurons, right? And if you consider 20% of that, that's about 102 or 103, around that. So 100 neurons will be dropped out, right? And they won't be used for connection, so there won't be any connection with those 100 neurons. So only 400 neurons will be available for training. Okay? And that's how dropout works in short. Okay, let's go back to our example. So I copied this from our previous lecture. For dropout, we also need to import dropout from Keras.layers. So add this line also, from Keras.layers, import dropout. I'll run the cell, and I copied this from our previous lecture to save some time. So it's the same thing, I didn't do anything else. I just copied this. So that's our data, right? We are trying to predict if a number is 7 or not. And here we have our initial numbers for byte size. Let's use 256, and number of epochs. let's use 10 or 15, it doesn't matter. And for activation, we have sigmoid. We have our model, sequential model. So this is our, let me comment it, input layer, right? This is our input layer, and this will be our output layer. Output layer. So where do we add our dropout? How do we know, what to drop? Okay, as usual, we start by defining our model, our sequential model, and then we'll add a dense layer and specify our input shape, and then we'll add an activation unit of sigmoid, and after that we'll add our dropout. We just add a layer called dropout, and in that layer we'll specify the probability. Okay, let's do that. So we have our model, and then we'll call add. We'll be adding a dropout layer, dropout, and then specify your probability. Let's use a probability of 23%. So 23% of your neurons will be dropped out. Okay, so same scenario like this. Okay, that's where you add your dropout layer. Once you add your dense layer and then specify your activation unit of sigmoid, you'll add your dropout layer. So this is a single dropout layer, a simple perceptron, and what we'll do is we'll add some more layers. Okay, I'll add two more layers, two more hidden layers. So let's call the first one first hidden layer, and we have seen this in the previous lecture. We'll first add a dense layer, and then let's use 512 neurons, and next you add your activation unit of sigmoid, model.add activation, and then pass sigmoid. Okay, and after that you add your dropout layer, model.add, and then dropout. So we'll pass a probability of 23%. That way we will drop out 23% of your neurons. Let's add one more layer, and we'll call this second hidden layer. So everything is the same. So we have our model.add. We'll add a dense layer with 512 neurons, and then we add our activation unit of sigmoid, activation, and then pass sigmoid, and finally we add our dropout layer and specify the probability. Okay, so that should be good. Okay, and finally we have our output layer and activation unit of softmax, so that our probabilities can add up to 1. And we call the compile method to configure the learning process. As I mentioned, it takes 3 parameters: loss, optimizer, and metrics, and we use the optimizer to minimize our loss. And finally we call the fit model, so that our model can train on the training datasets. So for our dropout, we add a dropout layer after our activation unit of sigmoid, and then if we have more hidden layers, we do the same thing by specifying the probability of dropouts. Okay, now let's run the cell and see our result. It says name model is not defined. Here it's model. Let me correct that and run it again. Let's run our next cell. Okay, now let's run our model.fit cell. Let me run this. So it will take some time. It has 10 epochs. Now it's running the first epoch. Loss is 73%, so every time we do additional epoch runs, we're trying to minimize the loss. And that's accomplished by our optimizer. Okay, so this might take about 45 seconds, it looks like. Okay, so now it has completed running. And let's run our model that evaluates cell. So this is just to print out our accuracy. Let me run this. Here we have an accuracy of 94.7%, right? So a little bit better accuracy. If you remember, our simple multi-layer perceptron model with just an input and an output layer, we had about a 94% accuracy. Now we have a 94.7% accuracy, which is much better than the accuracy that we had in the previous lecture, which was about 89% without any dropout layers. So with a dropout layer, now we have a better accuracy. And dropout is one regularization technique that we use to overcome the issue of overfitting, the challenge of overfitting. Okay? And as I mentioned, for your dropout, you specify the probability of your dropout. In this example, we used 23%. For you, as an exercise for you, you can try out different probability numbers for your dropout. Let's say try out 30% or 50% of your dropout and see what result you get. You can also add some more additional layers, or you can take out one of these layers and just try out to build a model with an input, one hidden layer, and an output layer, and compare your results. One thing to notice, if you have more and more hidden layers, it will take more time to run your model. And also, if you increase your number of epochs, let's say if you make this 20, 25, it will take some more time. And also that will also depend on the speed of your computer, and also whether you are using CPU or GPU. If you are running on a GPU, it will run much faster. So those are some other things to consider while building your model. Okay? If it's taking too much time, it could be one of the reasons that I mentioned. And again, dropout is just one technique of regularization. There are other regularization techniques. Another one is called L2 regularizer. I won't go into that, but just wanted to let you know that there are other regularization techniques. Okay? And you can read more about it or in depth in the documentation. Okay? So just an important note, in neural networks, there's a challenge of overfitting. So while you are building your model, think of all those parameters. Think of different ways to minimize your parameters and how it will affect your model. Okay? Thank you, everyone.